非常欢迎各位今天一同莅临 Playground 台湾共创次世代运算新篇章的记者会。我是今天的主持人楚文。那提醒您啊，我们的活动即将在5分钟之后正式开始，所以请各位人可以尽快就座了，谢谢。那我们今天呢，全程都有提供同步口译的服务，所以如果您需要口译的服务的话，邀请您可以到这个媒体的柜台呢去领取口译的翻译机。那当你领取到了之后，只要转到 Channel 1， 那么就可以来聆听即时的口译了。谢谢大家。那同时呢，今天我们7家来 Playground 的投资组合公司呢，都有在现场展示摊位。那在摊位上面都有展示现在最新最前沿的深科技的技术哦，让各位能够更加了解次世代运算的最新的发展。那也邀请大家呢，也可以在这个活动的中场或者是在这个活动最后结束的时候呢，可以逛逛这些摊位来更深入的了解。而我们也同时有准备茶点给各位，也请各位可以尽情的享用，谢谢大家。Ladies and gentlemen, welcome to today's press conference. I'm Ashley. Our event will be start in 5 minutes. Please be seated. We have simultaneous interpretation for the whole session. If you need a receiver, please head to the media registration desk right outside. Our staff will help you. And when you get a device, please switch to channel first for interpretation. Today, 7 of Playground's portfolio companies are showcasing their cutting-edge technologies in next-gen compute. We'd like to invite you to visit the demo area at the back of the room. And the light refreshments are available. Please enjoy. Thank you.
This.
在上面。没有，确认一下。
现场所有的媒体朋友们，大家早安，大家好，非常欢迎各位来到今天的记者会。那我们今天的记者会呢，有全程提供口译的服务。那刚到场的媒体朋友们呢，也再次提醒各位，如果您需要口译设备的话，可以直接到媒体的柜台来跟工作人员领取。那领取到了之后，只要调到 Channel 1，那么就可以有即时的翻译了。所以邀请大家，如果有需要的话，都可以来跟我们的工作人员洽询。谢谢大家。那同时呢，我们今天也有提供茶点给各位，各位可以尽情的享用。那我们今天呢，所有的投资组合公司也在现场有非常棒的这个技术展示的摊位，也欢迎大家呢可以来逛一逛。谢谢大家，我们待会见。现场所有的媒体朋友们，欢迎各位今天一大早一同莅临 Playground Taiwan 共创次世代运算新篇章记者会。我是今天的主持人朱楚文。Ladies and gentlemen, welcome to today's press conference. I'm Ashley, your host today. Playground 呢是来自美国矽谷的一间这个深科技的创投公司哦。从2015年成立以来呢，一直都致力于在次世代的运算，以及在能源转型，还有像生物工程以及自动化这些领域，携手顶尖的科学家，还有技术型的创办人，一起将这一些前沿的深科技实际落地到产业当中，去打造一个创新的生态圈。Playground Global is a leading deep tech venture capital firm from Silicon Valley. They invest in next-gen compute, engineer, biology, automation, energy to turn breakthrough ideas to the real world. 那今天呢 ，Playground 郑重的亮相了7间次世代这个运算的投资组合公司要向各位来介绍这些最前沿的创新的技术。同时呢 ，Playground 也会向大家来展现如何积极的去深化这些投资组合公司和台湾的半导体圈生态系的一些系列的合作，让这些前沿的科技呢能够走向全球的规模化，加速次世代运算的发展。Today, 7 of Playground's portfolio companies are here to showcase their cutting-edge technologies and how they are working with Taiwan's semiconductor ecosystem to move next-gen compute forward. 那在今天活动的一开始哦，我们非常的荣幸，也非常的开心。接下来要先跟各位来介绍一下今天到场从美国矽谷远道而来的 Playground 的长官和投资组合公司的长官们。那接下来我们请唱频道的长官可以起身和我们的媒体朋友来挥手致意一下啊。Now let's welcome our distinguished guests who will travel from Silicon Valley. When I call your name, please stand and wave to the media. 首先呢，让我们欢迎是 Playground Global 的合伙人 Pat Gelsinger， 欢迎 ，Thank you for being here。以及呢 Playground Global 的合伙人 Peter Barry，Welcome，Thank you for being here today。接下来让我们欢迎的是我们投资组合公司 Power Lattice 共同创办人、董事长暨执行长 Pongzhou，Welcome。以及 Pico Zhou 创办人暨执行长 Ellian， 欢迎。接下来让我们欢迎的是 Vertical Semiconductor 共同创办人暨执行长 Cynthia Liao， 欢迎。Welcome。以及 IR Lab 共同创办人暨执行长 Mark Webb， 欢迎。Welcome。再来让我们欢迎 D-Matrix 创办人暨执行长 C Chef，Thank you for being here。再来是 Next Silicon 共同创办人 L Nagar， 欢迎 ，Thank you for being here。最后呢是 X Light 执行长及财务长 Nicholas Callas， Welcome。那接下来呢，活动的一开始，就让我们以热烈的掌声，一起来邀请 Playground 的合伙人 Pat Gelsinger 上台，来为我们今天揭开序幕。Now please join me in welcoming Pat Gelsinger, General Partner at Taiwan, to the stage to open today's event.
Thank you, thank you, thank you. It is such a pleasure to be back in Taiwan, and maybe trip 50 for me to Taiwan over my career. So many long-term friends, and our meetings today just continue to deepen, broaden an enduring relationship. And as we think about this idea of the future of compute, what is coming next for compute? And this is where Playground Global, a unique, deep technology investment firm, is spending an extraordinary amount of its time, its energy, its capital, but working with some of the finest innovators. And when we think about the CEOs of our companies, the leadership teams of our companies, the first thing we care about is, are they the best technologists on that subject? Because to us, when you're solving the hardest problem, you need the best technologists to do exactly that. And we've created an environment, the playground, as you would call it. And if you come to the playground, what you see is an engineer's playground. Labs, research facilities, some of the brightest people that they get to interact with, portfolio companies in the playground. And of course, engineers only need three things. They need labs, computers, and food. And we provide all of those for them to do literally their best work in the playground. We operate and invest across these four areas, and we'll primarily focus today on next-gen compute, but also on our trip here we have some of our automation companies. We do unique work in energy transition, and finally engineered biology as well. And we think about this next period, and general partner and my partner at Playground, Peter Barrett, will describe this a little bit more in his comments today, but I call it the trinity of computing. And having spent my short 45-year career primarily on classical computing, we are continuing to see dramatic innovations in that area. But clearly the last 5 years have been dominated by AI computing. But the trinity is complete when we add to that quantum computing at scale, where literally we are able to now, between classical AI and quantum computing, be able to address almost every problem that can be expressed mathematically today will become solvable. We will move science from shooting darts in the wet lab or in the materials lab to becoming a structured, simulated process for the next generation of the world's greatest discoveries. That's what's going to be enabling that to occur. And with that trinity of computing, we see this opportunity as never before. My only disappointment in my 45 years in technology is I'm not 20 years younger. The finest days for technology and innovation are on the verge of the next decade or two. It is going to be that exciting. But why here in Taiwan? And now on trip 50 or so for me to Taiwan, there is no place like Taiwan. I sometimes joke that you can have an idea at breakfast, you can have a prototype by lunch, and you can have manufacturing by dinner. There's no place that innovates at the speed of Taiwan. There's no place that there is so much of the ecosystem as present in Taiwan. There is no place that there is so much of the supply chain, the manufacturing. Every company who wants to innovate finds its way to, through, and with Taiwan. This place is unique. And for that, it's our pleasure, our thrill to be able to be introducing some of our companies for the first time here in Taiwan. And to kick off our time today, I wanted to have a short conversation with one of our portfolio companies. And I'd like you to join me in welcoming to the stage the CEO of IR Labs, Mark Wade.
让我们热烈的欢迎Playground投资组合公司第一美国矽光子独角兽 IR Labs 创办人及执行长 Mark Wade 上台来进行炉边对谈的环节。这个环节呢 ，IR Lab 的 Mark 呢将会跟各位来分享现在最夯的矽光子的技术，以及如何会深化和台湾半导体圈的合作，重新定义运算架构。Okay, right now let's hand it over to Pat and Mark.
Very good. So, Mark, what caused this founding of IR Labs? You've been working in this space for most of your entire career, and what's inspired you to bring this about?
Yeah, thanks, Pat. And first, it's really great to be here in Taiwan. You've been 50 times. This is my 10th trip this year. So I'm not to 50 yet, but I'm probably on a trajectory to get there.
You will pass me.
That's right. IR Labs was founded on the premise that while computing was still making great gains and chips were increasing their computational power, the amount of data you could feed into and out of those chips was hitting some fundamental limits. And those limits come from the limits of electrical signaling and electrical I/O. And so myself and my co-founders, all the way back to our academic research at MIT and Berkeley, we started working on a new technology stack to bring optical communications and photonic communications into the CMOS manufacturing process flows to really enable a new kind of capability coming from these computing chips. So that was the thesis of starting IR Labs 10 years ago, and we've been working on that ever since.
And this idea of the communications bottleneck, I've talked about the need to switch from copper to optical for about 2 decades. And I've been wrong for a while on when that would occur. Your job now is make me right. Okay?
Yeah.
Right. And I do think of AI as that fundamental accelerant that is causing that to occur. Can you talk about that a bit, Mark?
Yeah, and the joke in the world of optics has always been that it's the next generation on the roadmap, right? So, but I think a few things have happened, and there's a few things that start to answer the question of why now. One, there's been this low-level technology trend that's been happening over multiple generations. But two, in November of 2022, whenever ChatGPT got announced, and the world kind of saw what the new paradigm of large-scale AI computing was going to look like. The issue with that AI workload is that it's severely bottlenecked by its chip-to-chip communications. So I'd say we had a couple of things that were timing at roughly the right time. Myself and my colleagues were making a lot of progress on the core technologies, and then we had the most exciting application maybe the world's ever seen that came on the scenes and really broke multiple layers of the kind of status quo hardware stack and accelerated the demand forward for things like optical connectivity. And one other thing that kind of people found interesting is a year ago when we announced one of our fundraising rounds, we announced that TSMC was investing, NVIDIA was investing, AMD was investing, and Intel was investing. And so there's this moment where it's become obvious that it's not a matter of if, it's when, and that when is coming in the next couple of years.
So why Taiwan? I think you have an announcement this week. Why is this so important and justifying 10 plane trips here? That's impressive.
Yeah. So one, it starts for us with, we want to build this optical technology and products where the high volume semiconductor ecosystem is. Because our customers build GPUs, accelerators, and AI chips that need this optical capability. So Taiwan is the center of the world in terms of where the advanced semiconductor manufacturing is. And I like to say you can get on a high-speed rail and have a design coming in and a full compute rack coming out. So that entire ecosystem is here. The foundry, the post-foundry, the OSATs, the connectors, all the way out to rack scale design and manufacturing.
So it's all here, but the question is it ready?
Yeah.
Right? Is now the time that this is going to start happening? I've been predicting it for 2 decades. Is it really going to tip over now?
Yeah, so let me comment on that a little bit. I'd say the way that I think about it is starting a couple of years ago, the technology was ready. And what I mean by that is we'd proven out all of the low-level technology. We solved all of the science fair problems, let's say, and showed that, hey, there's not big kind of open science questions at the low-level stack. We're now into the phase of engineering and manufacturing and how do we get this to scale. And that actually connects to the announcement that we just made today, which is that coinciding with the TSMC OIP conference happening down in Hsinchu, we've announced a partnership with GUC. And the way to think about that is, we're building optical engines, which I'll talk about here in a second with the hardware that I'm holding, but we need a whole ecosystem that knows how to integrate, package, test, assemble, and deliver optically connected products to the end customers. So I'd say that the phase we're in now is no longer kind of big open technology questions, but more building the right go-to-market partnerships, building out the ecosystem, and collaborating deeply with those players here in Taiwan so that the end customers have kind of viable manufacturing and high quality kind of paths to build products that are optically connected.
So the ecosystem is ready, you believe?
The ecosystem is on track to be ready, and people always ask me the timeline. What I can tell you is that IR Labs is aimed at bringing volume co-packaged optical solutions through the TSMC ecosystem in the 2028 timeframe in production intercepts. So I'd say everything is in motion, where the ecosystem is maturing, all the pieces are there, and it's a matter of driving the cycles of learning in the manufacturing scale into those volume intercepts.
And what are you holding there on the hardware, guys?
Yeah. So, and we'll have this over here at our booth if people want to check it out more in a little bit. This is a good example of the kinds of products that our customers are looking to build, which is that you have an advanced package with an AI accelerator or a GPU in the middle there, and you have optically connected optical engines on the package here. So this is, let's say, the world's most advanced package that has optical connectivity to it. And we build this in partnership with the work that we're doing in the TSMC COUPE process, and with our TSMC value chain alliance partnerships, like we announced with GUC today, and like we announced about a month ago in San Jose with a partner Alchip. So these partnerships allow us to build the integration capabilities to where you can have leading edge digital chips on there, high bandwidth memory packaged, I/O die, 2.5D, 3D IC integration using the TSMC technologies, and the optical engines that are integrated on the package that open up this optical connectivity set of capabilities.
Yeah, very good, Mark. So, it's a pretty exciting time for you, and a great announcement today.
Yeah, well, I've got one more thing. In Pat, it's been great to get to know you throughout this year and working closely together. And I'd love to figure out a way to get you more involved with the company. And so, I want to hand it to you to maybe announce something on your side.
Yeah, and in fact, we're just announcing today that I'm joining the board of IR Labs to help you finish the journey that we started 20 years ago. You and I, we're going to get this done, okay, buddies?
Thank you, Pat, and thank you, Mark, for those wonderful sharing. Thank you. Please make your way back to your seat. 那刚刚呢 ，Mark 和 Pat 非常精彩的跟各位来分享了这个矽光子相关，以及台湾呢在半导体的生态圈呢，未来呢将在国际间的这个重要的角色和地位。那今天呢 ，Playground 呢特别呢带了7家的投资组合公司哦，来到这个台湾呢，要跟各位来介绍。那接下来我们就要来邀请 Playground 的合伙人以及旗下投资组合公司的长官依序上台，带各位更多的来了解这些新次世代运算的投资亮点。相关的技术啊。Okay, please join me in giving a warm round of applause to welcome Peter Barry, General Partner of Taiwan Global, to share their vision for next-gen compute.
So 60 years ago, Gordon Moore penned this article, which initially chronicled and then drove the development of electronics. His vision was that over time, doubling components would lead to ubiquitous, inexpensive electronics. And he was right. Really nailed the details of how the economics of semiconductors scale. Now, 60 years later, we're turning on nuclear reactors to produce enough power to meet the voracious appetite of AI and semiconductors. And there are some people who are saying maybe Moore's law is dead. Maybe that scaling no longer applies in an age of AI. We're also seeing these extraordinary machines, probably the crowning achievement of human technology. This is an ASML EV machine. Most of them are here in Taiwan, and they consume a significant percentage of the Taiwanese energy grid. And it's taking these increasingly heroic efforts to produce these devices using this EV lithography technology. And maybe that feels like it's getting towards diminishing returns. So what do we do? Well, we've already heard the power of photons for interconnecting systems with IR Labs, but there are other degrees of freedom to apply the world's most powerful lasers to break open the limitations of EV lithography and extend the life and extend the possibilities that can be applied against EV lithography. We'll hear from X-Light, which is dramatically improving the power performance of EV. We also have degrees of freedom in new materials. Things like gallium nitride that can greatly reduce the losses of power conversion in delivering power to AI. We also have a company that you'll hear from soon that is meeting the demands of 3+ kilowatts that modern GPUs and XPUs demand. Now, there are other degrees of freedom. We're using the same architecture that was invented 80 years ago for our GPUs and CPUs. There are other ways of running software, and that we have an example here with NextSilicon, which today can run existing software 10 to 100 times faster than CPUs or GPUs. It's just a different approach to doing computation, and that's a huge degree of freedom, as is things like in-memory compute from companies like Deep Interest. Now, there's another important degree of freedom, also enabled by photons, and that is to use photons to build quantum computers. Drafting on the trillions of dollars in semiconductor investment, Quantum is building silicon photonics of unprecedented fidelity and is assembling it into quantum computers that are 10,000 times the size of state-of-the-art. 2 of these machines are under construction, one in Chicago, one in Australia. There's also algorithms that are developing 1,000 times faster than hardware in quantum. And we are now at a threshold where we can compute the uncomputable, where we can have agency over nature, materials, drugs, and chemistry. And that threshold is not decades away, it's not years away, it's months away. That will change the world. We're also in the infancy of AI. LLMs are not the end state, we are at the DOS age of AI. There are other ways of doing AI. It's more about learning the knowledge, and these architectures will shift the kinds of semiconductors we need to build to run on them. And one possibility is this technology. This is superconducting logic. It is 10 to 100 times faster than our fastest logic, and it uses 5 orders of magnitude less power. This is not a hypothetical technology. This exists. And things like this lead me to believe that we are not at the end of Moore's Law. We are right at the beginning of the computing revolution, and look forward to collaborating with Taiwan on realizing that potential. Thank you very much.
Thank you, Pat, for a wonderful introduction. Please make your way back to your seat. And next, we'd like to invite Pat to come on the stage again to introduce portfolio companies who will be presenting shortly. 让我们掌声欢迎 Pat 给我们介绍接下来投资组合公司。
Thank you. And I think the most exciting part of a startup is this moment where it first comes public. And we call that stealth. And when you come out of stealth, right, it's just this exciting moment where the secret, the technology, that breakthrough that you've been working on is first exposed to the market. And today we have 2 companies that we're using this opportunity to be here in this heartthrob of technology and introducing 2 new companies for the first time. And the first of those is Power Lattice. And what we've seen is this extraordinary demand for power delivery. CPUs have gone from 300 watts. Now we're talking casually around GPUs that are 3,000 watts. How do you get power to it? How do you regulate that power, and how much efficiency do you lose in that process? And being able to deliver a dramatic step function in that area is being accomplished by this company that I'm excited. Many of them worked for me at Intel in the past, and now seeing them come full circle to deliver a breakthrough technology for the industry. Please join me in welcoming Peng Zhao, the CEO of this company, to the stage.
让我们掌声欢迎 Power Lattice 的 CEO Peng Zhao 来给我们介绍全球首款电源供应小晶片如何重新定义次世代 AI 加速器的便利架构。
Hi, it's great to be here. Also, it's like Pat said, launching our company and also our achievements. So, power delivery historically is a low visibility job in SoC design. There hasn't been much change over the last 30 years. And this kind of bulky voltage regulators have been the norm for a long time. But today, that changed. Because power is now the defining challenge for AI's future. The power overhead due to the last inch of power delivery can easily double or triple the compute power needs, SoC really requires. So industry needs something different. So this is why we set out to reimagine power theory and founded Power Labs to break AI power wall. Today, I'm excited to launch the industry's first power theory chiplet here. So that cuts the effective power compute power needs by more than 50%. You can also easily integrate it in the existing SoC design, and it's already sampling to customers. It is also the only power chiplet available that can handle the current density AI requires. In fact, this tiny chiplet here can handle 250 amps peak current. To overcome the power degree bottleneck, we realized we need to move the voltage regulation from the motherboard into the SoC package. Current solution is just simply too inadequate for supplying the huge instantaneous energy needed when GPUs are running the workload. Like HBM broke the memory wall, we are breaking the power wall by delivering the power much closer to where compute happens, directly into the processor package. So how did we do it? This new power chiplet is based on our groundbreaking linear micro IBR architecture that combines miniaturized on-die-magnetic inductors, advanced control circuit innovations, a vertical design, and a programmable software. It tightly couples the power and compute, so we can precisely deliver the power where and when it happens. Despite its extremely small form factor, our chiplet is also packed with features to make it configurable and scalable. Customers can use many chiplets for a total power solution to power a given SoC. They can define many power domains. They can also define any shape and size of power domains as needed. So this such scalability and configurability can the ability to adapt any customer's SoC, even the existing one. A big part of our ability to deliver this chiplet is tremendous support from AP Memory, SoCo, and other wonderful Taiwan companies. Together, we can break the AI power wall and deliver the performance, efficiency, and reliability AI and data center infrastructure requires. Thank you.
Thank you, Joe, for wonderful introduction. Please move your way back to your seat. And next, we'd like to invite Pat to come on the stage again to introduce portfolio companies.
And AI today being limited by power, right? Not by capital, not by semiconductor capacity, but power. Super excited about Power Lattice. But we've already touched a bit in our IR Labs conversation on the challenges of optics. The challenges have been, unquestionably you can have higher performance, but can you do so with lower power and with lower cost? And fundamentally that has been the thing that has been keeping the copper technology alive. Today that ends. And from somebody who was born and bred here in Taiwan, it truly is a unique honor to have Al Yuan, joining us here with his breakthrough company called Picojoule that truly is finishing the job of replacing copper with light. Let's bring Al to the stage.
我们掌声欢迎 Picojoule 的创办人 Alan 来跟我们分享 Picojoule 如何以高效能、低成本的光学连接技术，重新打造更高灵活度的 AI 资料中心网络。
All right, good morning. As Pat mentioned, I was manufactured too in Taiwan. I went to Silicon Valley when I was 7. Grew up there in Silicon Valley and started many companies, but I wanted to spend one moment to talk about Playground. They're extremely unique. Just by the age of this entrepreneur that stands in front of you, they don't do anything typical, right? They're betting on real people, founders that are working on big problems and with big ideas. And so really, you're going to meet, you already met Pat and Peter. I hope you'll say hello to a lot of the Playground folks that made all this happen. It doesn't just happen overnight. Chica, Kendra, who makes everything happen, Hadley, Daniel, Sarah, they're all here, so I hope you'll get a chance to meet them as well. So let me talk a little bit about Picojoule. So my team has been doing parallel optics for over 30 years. We came out of both Berkeley and UC Santa Barbara, which is an institution that's been building photonics since the late 80s. And our technology that we're basing all of this on is called a vertical cavity surface emitting laser, which we're showing in the first left figure there. It's a unique laser. It's vertically integrated and also vertically emitting, and that's able to be tested on a wafer scale. We're partnering with WIN Semiconductor in Taoyuan. Taoyuan and WIN Semiconductor has been the VCSEL premier manufacturer in the world. My team introduced the VCSEL to them back in 2016, and then they basically rose throughout the international supply of VCSELs. And then if you have an iPhone in your pocket, it's likely that it's made by WIN Semiconductor and is used for your Face ID. The other is when we have the VCSEL technology at 100 gigabit, we're working on 200 gigabit. We also have the technology to build it into extremely small modules, which we call massively parallel optical links. Right? As Pat pointed out, cost to displace copper is really the key, and by massively putting these parallel optical channels together, we can drive the dollars per gigabit cost to be comparable with copper. And as copper is running out of distance, right, copper at 200G can only go about 1 meter, we can go still up to 30 meters with a copper comparable pricing for these terapod demonstrations that we're doing. So let me use the analogy of moving. So if you're going to move your house, you have all this stuff you want to move, surely you can use an extremely high-speed sports car with a car rack, but it's going to take you a lot of trips. If you go to massively parallel optics, what you get is you get many, many channels. So we're working on a pluggable 64 channel by 100 gigabit. It does not require a digital signal processing chip, so that takes out half the cost, half the power, and more importantly, half the space. And so we can put 64 channels in the size of today's QSFP or OSFP pluggable transceiver. And the good news there is that the 19-inch rack that a system is built into is limited by that 19-inch rack. And so as the bandwidth increases, we need to squeeze more bandwidth density in order to supply all that connectivity. And this is the next generation, which we're calling MSFP, standing for Massively Parallel Small Form Factor Pluggable. All right, thank you.
Thank you, Alan, for a wonderful introduction. Let's make your way back to your seat. And next, we would like to invite Pat to come on the stage again to introduce another 4 portfolio companies.
One of the joys of being no longer a CEO but a venture capitalist, I get to work and help other CEOs and their opportunities, their visions, and help them become great leaders. It also means I have to no longer have my hands on the wheel. Their hands, and sometimes they remind me that I'm not the CEO anymore. And, with that, these 4 companies we'll also be hearing from today. Vertical Semiconductor, right, is truly taking gallium nitride and replacing the entire spectrum of voltage conversion. Truly something that will enable new breakthroughs in power. Excited to hear from Cynthia today. Next, Silicon. as a long time, I spent the bulk of my career as a microarchitect in CPU, high performance, floating point arrays, and what that looks like. Next Silicon is, I believe, the first breakthrough that will allow us to leap beyond today's CPUs and GPUs and truly define the next generation of architectures. Third company you'll hear from is D-Matrix, and this idea of in-memory computing and what it takes to do AI more efficiently. We don't need to make it 10% or 2x better, we need to make it thousands of x better, and you're going to hear incredible breakthroughs by Sid and the team at D-Matrix. And finally, here in Taiwan, more of semiconductor manufacturing is done than any place in the world. A big, enormous capital fab at 20+ billion. In the middle of that is EUV, representing about half of the capital budget. But in the middle of EUV, light. And God said, let there be light. And today you'll hear about the next generation of light sources from Nicholas. So with that, let's get started with Cynthia and Vertical Semi.
来跟我们分享垂直式的氮化镓功率半导体技术如何可以打造一个更棒、更有效率的电力转换方案。
Good morning, everyone. I'm Cynthia Liao. 各位来宾早上好，我是廖亮。I am the CEO and co-founder of Vertical Semiconductor. Together with my co-founders Josh Perozic and Professor Tomas Palacios, we're commercializing breakthrough technology developed at MIT. Our mission is simple and ambitious. We're bringing to the world vertical gallium nitride power transistors, vertical GaN. With vertical GaN, we will build and enable the foundational power layer for the next era of compute. Everyone is talking about compute, faster cores, more chips, and larger models. But as you've heard today, the true bottleneck to AI build-out is power. We are seeing a massive increase in the power density that's required for every single data center rack, 50 to 100 times. What's very clear is that power architecture inside the data center is not keeping up with this increase. But the trend is clear. There is a need to deliver higher and higher voltage power distribution from the 48-volt architecture that we see commonly today to 800-volt DC and beyond. The industry is calling for devices that can simultaneously deliver higher voltage, high efficiency, high power density, all with much better thermal capabilities. And that's where Vertical Semiconductor comes in. Vertical Semiconductor is commercializing next-generation technology that was developed over 8 years of research at MIT. Our innovative, truly vertical architecture enables us to bring the benefits of gallium nitride, so fast switching capabilities and world-class efficiency, to a scalable voltage classes from 40 volts to 1.2 kV, with 2.3 kV in our roadmap. We're doing this all on a much smaller device area and with much better thermal performance than state-of-the-art technologies out there. When the industry is calling for high efficiency, high density, high voltage, vertical GaN will outcompete state-of-the-art lateral GaN and silicon carbide. But I'm even more excited to share with you our manufacturing breakthrough. We're pleased to announce that we are the first company in the world to commercialize our technology on 8-inch wafers in a process that is entirely compatible with CMOS foundry capabilities. What this means is that this technology is ready for production at the high volumes needed for the data center market, and also leverages the fabless, cost-effective approach of being able to go to market without building out an entire foundry. And so we're very excited to prove that we can develop next-generation technology with cost-effective manufacturing processes. Vertical Semiconductor is about to revolutionize power delivery inside the data center. We can apply and deploy vertical GaN across every single power conversion and delivery element and application in the data center, from the grid to the chip. Compared to state-of-the-art silicon carbide, we're driving a 30% reduction in losses, as well as a 50% reduction in the footprint required. What that means is that we're able to deliver simpler, smaller, more efficient power delivery systems for data centers, all with a much reduced total cost of ownership. Because the future of data centers is not just about how many GPUs it has, but how efficiently we can power them. With Vertical Semiconductor, what we can do is take power that is currently being lost to power systems and square footage that's currently being lost to bulky power systems, and actually convert all of that to enable more and more compute, turning power from a cost center to a true revenue driver. And today we are so excited to announce our early sampling program. So I invite you to come join us and sign up for our waitlist to get early access to state-of-the-art technology from Vertical Semiconductor. Thank you so much.
Thank you, Cynthia, for your inspiring presentation. Please make your way back to your seat. 那紧接着呢，我们下一位要来介绍的是 D-Matrix 的创办人及执行长 C-Chef， 他要来分享团队如何以创新的记忆体运算整合和软硬体协同的设计技术呢，来打造高效能的 AI 推论解决方案。让我们掌声欢迎 C-Chef。
Hello everyone, ni hao. Very nice to see all of you. So I'll be talking about the company D-Matrix, which is focused on inferencing compute. We are a next-gen computing company that is building an accelerated computing platform for generative AI inference. And our goal when we started the company in 2019 was very singular. We wanted to make world-efficient inference compute that was sustainable and affordable for every human being on the planet. So we had a big announcement last week. We raised our Series C round, which was a $275 million round that valued the company $2 billion. And this brings our cumulative funding to $450 million. Playground has been an early investor in the company from Series A, so we're very thankful for their support. We plan to use this capital to deploy our products, ramp them in production. I'm here in Taiwan this whole week talking to numerous partners as we start scaling our product across multiple customers. So what is it that D-Matrix does differently? So the first thing we realized about inference compute was that it is not just a compute problem, it is a compute and memory problem. So you have to optimize for compute for sure, but you also need to optimize for things like memory bandwidth and memory capacity. So to that extent, we built a new class of compute engine, which we call the digital in-memory computing engine, where we fuse compute and memory, specifically SRAM, in a single bit cell. And what that allows us to do is to essentially keep all the model parameters in the same location without having to move the data too much, which obviously means we save a lot of energy, we save a lot of time. Now, if you want to scale a platform like this, we realized that we had to find a way to pack more memory with the compute. So we essentially found a way to pack or essentially stack DRAM directly on top of the compute tile. Right? So now we can essentially build a skyscraper, call it, of chiplets with compute and DRAM and put many of these on a single board. So with this approach, by the way, this was something that we worked with the Taiwan ecosystem to create a recipe to pack DRAM, custom DRAM and compute. But with this approach, we can have up to 30 gigabytes of this compute DRAM stack on a single PCI card. We can do up to 300 gigabytes of this high-speed memory in a server, and close to 2 terabytes plus in a single rack, right? So this allows us to serve fairly large scale models using this approach. This is our go-to-market, and last year we announced a product called Corsair, which I'm always proud to show off if I get an opportunity. And this is the product. I'll hold it up for you, and it's a bit heavy, so I can't hold it up for more than maybe 3 seconds. I'm counting down. 1, 2, and 3. Thank you. I'm not as strong. It requires a little bit of a workout. So that is our inference computing accelerator, and that we typically our business model is to sell cards. We are in the business of selling hardware. We don't really build compute accelerators. We recently announced an I/O accelerator called Jetstream that goes along with this, and we work with the ecosystem. We work with server partners, rack partners that assemble these cards into a solution. So when we go to our customer, we are typically not selling the whole solution, but we give them the flexibility to decide which server vendor they want to work with which rack vendor they want to work with, what type of cooling they want to use. Our solutions are agnostic, and we will work with pretty much any type of ecosystem to augment that infrastructure. And that allows us to stay very focused on what we do really well, which is building silicon, software, cards. Finally, big week for us in Taiwan. We are announcing 2 partnerships. So we are announcing a partnership with Andes, that is our RISC-V computing partner, and they're going to help us build our next generation product called Raptor. We are also announcing a partnership with Allchip, that is our ASIC partner, that is helping us assemble the Raptor solution. The Raptor solution is our DRAM and compute stack solution. Very excited about partnering with Taiwan. We would love to, we're obviously growing with Taiwan together as we build out our roadmap. And I look forward to seeing some of you in the after presentation. Thank you.
Thank you, 谢谢 for a wonderful presentation. Please make your way back to your seat. 那紧接着呢，我们要邀请的是 Next Silicon 的共同创办人 Al Nagar 上台来跟我们分享软体定义的硬体架构，以及创新的技术如何重新定义高效能运算，加速超级电脑的运算效能。
Thank you, Sid, for coming with this innovation idea of the chair. It's always good to have a bigger problem before you solve by someone else. So I'm here to introduce Next Silicon. Proud to do that. Next Silicon was founded in 2017. We are here 8 years. We have 400 employees. All are driven by the mission to reinvent the future of compute as part of Playground family. We've got $300 million in funding, which allowed us to tape out 2 chips today. The first Maverick was taped out in 7nm TSMC. And then we taped out a high-end RISC-V CPU, the most powerful RISC-V in 5nm. And today, I'm very happy to announce here in Taiwan our next generation Maverick 2 chip, which is already running at our HPC labs and delivering high performance in low power. And by the way, thank you for manufacturing this baby monster. Our go-to-market strategy was to start first with HPC and then expand our technology to the AI space. As everyone said here, the biggest power of compute is power. The biggest problem of compute is power. Our intelligent compute architecture delivers 4x performance over GPUs and 20x over CPUs. What you can see here in this diagram is that we are all hitting a power wall. We get more performance, but in the expense of high power. Here in Taiwan, there's a lot of innovation happening. We've got 3nm chips, soon 2nm, large-scale packaging with 2.5D and 3D, amazing servers and racks that are solving this power problem, but we still have chips that are 3,000 watts. And Next Silicon, we came to solve and break this energy wall. The way we do that is with our novel data flow architecture that is not new, actually, but it delivers higher performance for lower power. Data flow is known to be the best architecture for accelerating power workload, but it was difficult to program. And Next Silicon, we spent the last 8 years to solve this problem with our intelligent software. So basically, we make this problem a non-issue for the users. You simply get to run your code and accelerate it using the data flow architecture. So you get higher performance with lower power and an ease of use. So what I would like you to take from here is these four values that we want to bring to the market. We're going to get performance with lower power, and we're going to make it easy for everyone to use. You can simply take application as is. But most importantly, this technology is just the beginning of what you can do with data flow. There's so much innovation you can do. It's software-based, and whenever a new algorithm or a new idea will come from the HPC and AI world, we will be ready to power it and run it on our chip. So you might say, okay, that's a nice vision, but is it really working? The answer is yes. We have it working, we have it running on our hardware with real benchmarks out of the box, and in this performance. And by the way, we've got it to run at scale with our Vanguard 2 supercomputer. So it's not only a single device solution, it's a large-scale solution, and all of this hardware is made in Taiwan. So we want to thank you very much to be our partners, and we want to encourage you to go and work with us in bringing this area of intelligent computing to life. Thank you for that opportunity.
Thank you, and for an inspiring presentation. Please make your way back to your your seat。那最后呢，我们要邀请的是 Xlite 的执行长暨财务长 Nicholas Callas 来跟我们分享团队如何以全球最强大的自由电子雷射 FEL 技术来取代传统雷射等离子光源 LPP， 来为先进的半导体制程带来革命性的发展。
Good morning. What you'll soon see is that there's not enough chairs here to support an example of what we're building in Xlite. So I'm proud to introduce Xlite, where we're essentially building the world's most powerful lasers to transform advanced semiconductor manufacturing. And specifically what we accomplish with this is Xlite makes advanced chips better in terms of capabilities and performance. We make them faster in terms of the production capabilities. We can double the productivity of the most important tool in advanced semiconductor manufacturing. We make them cheaper. We can reduce the cost by almost 50%, and we make it more sustainable. So we take the most power-consuming tool in the semiconductor supply chain, and we reduce its power consumption by 500%. And the way we do this is by addressing the most important tool in semiconductor manufacturing. We've already both heard from Peter, EUV lithography is an amazing accomplishment. This drives the capabilities of our semiconductors, but it's fundamentally constrained by light. And so what Xlite does is we deliver nearly unlimited light to not only unlock the capabilities that already exist in the tool, but are constrained by its current light source, but we also open up the opportunity for the next generations of innovations in the tool, which will drive the next generations of innovations in semiconductors. And the way we do this is by fundamentally changing the paradigm of light at the fab. So we move from tool-based light sources that are inherently constrained by size and cost in their performance, and we build outside the fab at utility scale. The same way you do power, the same way you do process gases, the same way you do HVAC. And so this allows us to deliver substantially more power, up to 4 times more EUV light to the scanners. This drives not only capabilities in lithography, it drives yield, and it drives productivity. Building at utility scale also enables a whole different business model. So the same way the fab pays for its power, its processed gases, we sell light as a service. So when we combine light as a service business model with higher productivity, that's what enables us to reduce, in the simplest cases, the cost of the most important step, the most expensive step, by 50%. Finally, these facilities have an incredible lifespan, operating 30 to 40 years, a broad range of tunability. So as delivered, our FEL light source not only drives EUV lithography today, but that same light source is already capable of delivering the next generations of light to drive future lithography, future metrology, and future inspection layers. So what does this look like? So here we have the fab on the right, Xlite source on the left. What you'll see first is we build underground. And we can be up to 1 kilometer away from the fab. So this allows us to be able to deploy at the highly condensed fabs and allow things to be built over the top. You'll see very mature particle accelerator technology, similar to what you find at the Taiwan photon source over in Hsinchu. We use these to create electron bunches that we ultimately drive through free electron lasers to deliver EUV light to the scanners. As that light is generated, we direct it up into the fab using grazing incidence optics. And then what you'll see shortly is that we actually take the whole system and we have complete redundancy. And that allows us to deliver 99% availability that's required for semiconductor manufacturing. Once the light's into the subfab, we direct it up into the scanners in the exact same path as the current drive lasers, or LPP. And then inside the scanner, we reproduce what's called the intermediate focus, so that for the rest of the scanner, this is a completely transparent process and allows our sources to be fully ground flow compatible and electrophilic. And moving beyond animations, we're already building this technology now. So our prototype is underway, and we'll have first light in 2028. And because we're leveraging mature technologies that exist in science facilities around the world, we're already collaborating with our ecosystem partners to do the foundational development to ensure when these systems come online for commercial applications, we're already ready to fully leverage the unique properties of the computer. Thank you.
Thank you, Nicholas Callan, for your wonderful presentation. Please make your way back to your seat. 非常谢谢以上所有投资组合公司非常精彩的介绍，相信也让各位更加的了解这些次世代运算的深科技的技术以及台湾半导体产业圈连接的合作。那接下来呢，最后我们要再一次的邀请 Pat 上台来为我们做个总结。To conclude today's session, let's welcome Pat back to the stage for the closing remark. Please give him a round of applause.
Many years ago, I think it was 41 years ago, I was on a stage like this, and the other person on the stage was a industry leader named Andy Grove. And for that began a launch of an era that for many in Taiwan was the beginning of their companies, the beginning of a period of innovation. Many of those people that you've gotten to know as the business leaders of today in Taiwan were at that event as we kicked off that moment some 41 years ago. Here we are today with the next generation of innovations that you've just seen in front of you, with the next generation of CEOs and leaders, a next generation of an industry that isn't done, it isn't mature, it literally is producing the innovations that will yet again be changing the world. And it really is an honor to be able to present these next generation companies, their leaders, to you in Taiwan today with some new announcements, some new technologies, but more than anything, the same spirit of innovation that we launched 41 years ago, continuing today. Thank you very much.
Thank you, Chris, for your wonderful sharing. Please welcome everyone on the stage because right now we are moving on to the media photo session. We'll start with a solo photo of Pat. 好，接下来呢是我们的这个媒体的这个拍照的时间啊。那我们邀请所有的媒体朋友，如果有需要的话，接下来我们先进行的是 Pat 的读证。那待会我们也会邀请到 Peter 还有其他的投资组合公司的掌柜一同上台。那我们请有需要的媒体朋友可以往前来进行拍照。Okay, let's look straight to the camera. 好的，那今天有很多的媒体朋友都来到我们当中哦，非常谢谢大家呢，今天一大早呢，用这个宝贵的时间一起来了解深科技次世代运算的相关技术。那还有没有媒体朋友？好，不在中间哈。Okay, let's look straight. Maybe with a thumbs up. 好，那有没有 ？Okay, 好 ，Let's look to the right for the media friends. 好，今天真的是非常的开心。那有很多媒体朋友到现场，还有媒体朋友拍照，可以帮我挥挥手，我就会请长官呢看向你的方向哈。Okay, let's look at the right for the media friend again. 好，这边还有媒体朋友要拍照哈。Okay, thank you, Pat, and please remain on the stage. We'd like to invite Peter to join Pat on the stage for a group photo. 那接下来我们邀请 Peter 和 Pat 一起来进行合影。有需要的媒体朋友，你可以来跟我们的来拍照。好，那我们也特别邀请媒体朋友，待会呢一定要到我们今天展示的摊位来逛一逛啊，因为在现场我们都有展现出这些最新的次世代运算的相关的深科技技术。那在现场也有展品，大家可以实际的了解一下这些技术以及和台湾半导体产业的连结与发展。OK， 那还有媒体朋友需要拍照的，没有拍到您的那个方向的，可以帮我挥挥手。Okay, and now we'd like to invite Pat and Peter remain on the stage and welcome all the CEOs of the portfolio companies to join on the stage for a group photo. 我们要邀请所有的投资组合公司的 CEO 一起上台来进行合影。Power Lattice, Picojo, Vertical Semiconductor, Iron Labs, D-Matrix, Next Silicon, X-Light, please come up for a group photo. Okay, let's please step a little forward to the left. Thank you. Okay, let's look toward the center. 今天呢，所展现的都是会影响到半导体未来发展非常重要的一些相关的深科技的技术哦。那很多也是大家我们媒体朋友们非常关心的。好，也谢谢媒体朋友们今天到场来进行采访。好，那因为今天的媒体朋友呢，人数比较多哦，我们也请前方的媒体朋友，如果您拍好照的话，可以帮我们稍微蹲低一点点，让我们后方的媒体朋友也可以拍到照。因为我们今天有很多电视媒体朋友呢，在最后方啊有摄影机，他们也需要录影的部分，谢谢大家的帮忙。Okay. And now we'd like to invite Peter to stay on the stage for an individual photo. As for Pat and the CEOs, thank you. You may now return to your seat. Thank you. 好，接下来我们要请 Peter 留在台上拍摄独照。有需要的媒体朋友可以捕捉镜头。OK， 还有没有媒体朋友需要拍照？可以挥挥手，可以特别来帮您的忙。OK，Thank you, Peter. Please return to your seat. Thank you. 好的，那接下来呢是我们的电视联访的时间啊，我们要请 Pat 和 Peter 呢来到舞台上，好，待会会进行5分钟的，我们先让电视媒体朋友的采访。那待会那个平面还有网络的媒体朋友呢，请在座位区稍作等待啊。我们电视媒体采访的时候呢，大家会轮流进行安排。
是有3只吗
？Okay, next we will move on to the TV media.
请他们动作。
没有。等一下，我没有手。等一下，我没有手。我太多了，太多了。提问的部分也麻烦。我知道提问的电视媒体朋友可以直接提问，有问题吗？可以直接提问哦。
So can you just briefly introduce your company and the cooperation with Taiwan?
Yeah, Playground is a deep tech investor where we focus on the hard, the deep, the revolutionary, and ultimately dramatically industry-shaping companies. Today we announced 2 new companies, one in power delivery named Power Lattice, the other in optical connectivity. Picojoule were first announced today here in Taiwan. And all of the companies that we have take unique benefit to the innovation, the speed, and the supply chain and manufacturing that are here in Taiwan. So it's truly a pleasure to be hosting so many of these innovative companies with their next generation leaders here in the place that innovation meets the market, Taiwan.
And you've mentioned you have been to Taiwan for 50 years. So what reason brings you to here so many times?
Well, the reason you come to Taiwan is the cycle of innovation that's possible here. And these companies that we had the pleasure of introducing and presenting to the market today, all of them will be integrating with, working with, partnering with, and using that innovative cycle of Taiwan. They need to be here. And we, Playground, are looking forward to increasing our presence, visibility, partnerships, investment with the vibrant Playground and Taiwan partnership that we're expanding today.
And how do you see the collaboration with Taiwan so many years?
You know, Taiwan, when I first came here, it was a little place. It was hungry, aggressive, but still very tiny and immature. Today, 40 plus years later, it is the center of innovation for the technology world. That happens here in Taiwan. So any technology company, and like we've seen for our partners that we have in our portfolio companies, they need to be in Taiwan. Taiwan is the place where innovations come to market.
There are a growth discussion of a AI bubble. From your perspective, is the current wave of AI investment sustainable, and what indicators do you watch to judge whether the industry is overheating?
Well, look, I think we are in the infancy of AI. Okay, where we go? So we're in the infancy of AI, right? We're right at the beginning, not right at the end, and that there will be some technologies that succeed over others. But look, civilization is built on computation. Computation is made here in Taiwan, and I think we're just right at the beginning of something, not right at the end of something.
And fundamentally, the biggest limiter for AI isn't capital, right? Lots of people are throwing money at the AI industry. It isn't semiconductor capacity. In fact, it's power. And then part of the excitement of today is some of the companies that we've brought forward today for the first time are exactly attacking that issue. How to make AI more power efficient, how to deliver more power to the AI technologies. So this is an exciting moment to address the core issue of continuing to deliver on the AI promise.
So the AI bubble, what's your timeline for this correction?
These, clearly, there are disruptive cycles, like in every major industry, and now we're seeing some of the highest multiples, some of the highest concentrations of capital. Of course there's a bubble, but at the same time it's undergirded by the most foundational, transformative technology in our era. We have decades of growth in front of us.
好，因为时间关系，我们就最后一题，谢谢大家。
So you mentioned that many like other tech companies come to Taiwan because here's like a place that has a really good innovation. But what about your thoughts on because recently President Trump mentioned that more companies, the chip-making companies, business going back to the U.S.
Well, I've been arguing for many years that we need more resilient supply chains. And I still believe that's the best policy for Taiwan, the best policy for the U.S., and the best policy, for the world. Over-concentration in any one location isn't good for the industry in the world. But, this is a place where so much of that has emerged. It's a place where they have, emerged at scale over decades. But, I do think that more balanced supply chains is the best, approach. And clearly this administration is one focused on that with respect to the U.S. But the world needs growth in the supply chains and more resilience in the supply chains.
好，谢谢所有的电视媒体朋友。Thank you, Pat, and the picture, and please remain on the stage because we're now move on to the interview session with our friend and online media for 3 minutes. 好，那接下来我们是我们影片媒体朋友还有网络朋友的提问时间。那如果你有任何问题的话，可以举手，我们的工作人员会第三个帮你提问。那这个时间呢，大概是10分钟的时间，邀请大家也在提问的时候，先跟我们来介绍一下您的媒体单位，谢谢大家。
我很委婉，我很委婉，又把球。
Startup here working with Taiwan supply chain, and given Taiwan's advanced position in chip manufacturing, we're seeing a lot of the startups using TSMC process. But still, many in the industry still have concerns about Trump administration's policy regarding tech. Regarding the tech industry, the chip industry. So in a position like yours, where you are helping startups to connect with Taiwan, do you still have any worry that the Trump administration is still seeking to punish Taiwan for our dominance in the semiconductor industry, or do you see in this case the U.S. manufacturing, the U.S. effort in putting more advanced chips in the U.S. may fail? Thank you so much.
Clearly, the role of semiconductors is not diminishing in the world. The industry of semiconductors continues to grow. By the end of the decade, will be in excess of $1 trillion expected. This is foundational for all of technology. Technology is foundational for all of industry. Industry is foundational for all of the economy. Everything rides on the foundations of semiconductors. And as such, I believe that having more resilience to those supply chains is the best policy. And for that, I'm very much supportive of the Trump administration wanting to see more built in the U.S. That doesn't mean there's less in Taiwan. It just says more of the growth should occur in other geographies like the U.S. Clearly TSMC is building in the U.S. I encourage them to have more advanced nodes and more R&D in the U.S. because it simply is better policy for the world. It is so important to the future of the world. We need more resilience in the underlying supply chains of the most important technology, semiconductors.
好，非常谢谢这位媒体朋友的提问。那有没有其他媒体朋友需要提问的呢？也请您举手，那就跟我们介绍一下您的媒体单位，谢谢。好，我们今天口译老师也在这边 stand by， 你也可以用中文提问，口译老师会协助为您翻译。好，我们有请那位在倒数第2排的男性媒体朋友。
I'm from Wales Magazine. I'm just curious because Pat, you are involved in the development of UV. So how you see the future of the light source? Because the whole world is seeking for the answer.
Yeah, thank you. And EUV, right? It was miraculous that this whole LPP, this tin droplet being smashed with laser, could produce the 13.5 nanometer light. That's at the center of today's EUV machine. This was an engineering marvel. That said, that light source, that LPP light source is limited. It can only produce one wavelength of light. It can't scale in additional power very effectively, and it is rather power inefficient, right? So today I think about 10% of Taiwan's power goes into semiconductor manufacturing, and about half of that is into lithography alone. We need more power efficient, we need more scalability. What Nicholas described with X-Light, we believe that we can take light to below 2 nanometers, so 13.5, maybe 6.5, 4.5, all the way below 2 nanometers, and have it at much higher power with much lower input power requirements. That's magic. And that's what we believe the promise of free electron lasers and X-Light is. And that's why it's so important that we bring this technology to the semiconductor industry, but also bring it to Taiwan.
好的，非常谢谢这位媒体朋友。我们有请这一位前方的女性媒体朋友。
Hi, nice to see you, Pat. I'm Elaine from Commonwealth Magazine, and I do have 2 questions. One, following on Hongda's questions about EUV, because several weeks ago we do see a startup in the US called Substract. They also announced some kind of EUV solution, and I'm wondering your idea about that solution. Will that be a disruptor to ASML, or what's your opinion on this? And another one is, like you do bring a lot of startup here to Taiwan, and many of them are to solve the bottleneck of the electricity, especially for the AI data centers. So what do you think will be the most key challenges that should be solved that could probably solve the problem of the challenge of the electricity? Thank you.
Yeah, on the first, obviously we are working on solving one problem. That's next generation light with X-Light. Substrate has suggested that they're going to be able to solve many problems. And I think there's been much written on the aggressiveness of their claims, not being associated with that company or technology. It's hard for me to comment further. We think the approach that we're taking is the right one. Solve the most important problem. And the hardest piece of lithography is about light. That has been the case for decades, that's the case today, and if we solve light, many other good things will happen, and that's exactly what we're doing with X-Light. On the power side, you've seen here today, you've seen 3 different things addressing power, right, which to me is very important. How do you use power in computation more effectively? Both D-Matrix and Next Silicon are doing that. How do you convert power more effectively within the complex of the compute? That's what you heard Power Lattice do. How do you get power more effectively to the data center? That's what you heard Vertical Horizons doing. So through all of those, a theme of power efficiency in getting power there, getting power converted, and using power effectively. That's a pretty powerful combination, pun intended, to address the AI power challenges. It is the fundamental limiter in continuing to scale AI computing. Peter?
And Pat, if I may, there are wild alternatives to semiconductors and transistors. There are radical departures from our current AI architectures that are not hypothetical, but are being worked on within the program portfolio. So we have best-in-class that are changing and revolutionizing current ways of doing AI and computation, but there is a long set of degrees of freedom to dramatically push the envelope beyond what is currently state-of-the-art. And again, those things are being worked on today. They're not something in the far future.
好的，那还有没有媒体朋友 ？Here.
Hi, Chris Gorin with Taiwan Plus. Obviously, some of these announcements today show that you have a lot of confidence in Taiwanese manufacturers, but there's still one big unknown. I'm thinking specifically of Section 232 tariffs on semiconductors. I'm just wondering how Playground views that risk and how you incorporate that risk into your investment decisions.
At the highest level, it isn't our biggest concern. Right? We're working on core innovations, and we work with the industry, the ecosystems of the world, and we have portfolio companies that span the globe. We're mostly based in Silicon Valley, as many of these innovations are placed there, but it isn't our biggest concern. That said, we are very active with government affairs around the world. Because sometimes it's non-dilutive capital, it's research partnerships, government policy formation, and a number of our companies have very active discussions with the governments around the world, and the U.S. government in particular. That said, we like everybody else are affected by those policies, so of course we study them. But when you're working as far upstream as we are, the policies of a decade from now aren't necessarily the ones of today. So we're focused, do great technology, and we'll figure out some of those challenges as we get closer to market.
好的，因为时间的关系，那我们最后3个问题，来有请这位媒体朋友。
Digital Smart Car. I have.
Good to see you again.
I love so much. 我想问3个问题。第一个问题是，20年前您先投入 AI 研发，那现在的 AI 发展非常的蓬勃，但是最近有一些 AI 的泡沫声浪。那您作为前辈，您如何看待这样的一个趋势？然后第二个问题是近期的 AI 的发展，像 CSP 大厂，它的资本支出不断的提升，那各家大厂也突然绕着 OpenAI 跟 NVIDIA 进行大规模的投资合作。您如何看待这样的生态链是否是正常的发展？第3个是您这次带着7家的公司在台湾亮相，也寻求跟台湾半导体供应链的合作。那您刚刚也说了40年前的跟台湾的发展故事，但是台湾在40年后还是在硬体产业打转。那对于这个这一个发展，你对台湾产业有什么样的看法
？3 questions. And the first one, well, 20 years ago, you were among the pioneers in talking about AI. Now AI is thriving and growing, but there are also some skepticism about an AI bubble. What's your perspective on this? The second question is about the capex of CSP and the huge investment surrounding NVIDIA and OpenAI. Do you think this is a normal path for such development? And the third question is about your portfolio company, the 7 of them that you're showcasing in Taiwan right now, and they're going to work with the semiconductor supply chain in Taiwan. Well, 40 years ago and 40 years later, Taiwan is still specialized in hardware. So what's your perspective on the industrial development of Taiwan?
You want to start with the bubble?
Yeah, look, I think that there is some inefficiency in the way some of the capital is being deployed in AI, but as I said, AI is one of the most important and underhyped technologies, as well as being one of the most overhyped technologies. And I think its utility will outlive certain discontinuities in efficiency of capital deployment, right? So not everybody is going to make money on their foundation model investments, but AI will be foundational moving forward. But the AIs we have will change, and I think that we are in the DOS age of AI. That will evolve into something that works differently, that drives different demands for computation, and I think that this temporary inefficiency will give way to real, durable utility.
On the cloud investments, I am not very concerned about them being overly stated today because fundamentally they're limited by energy availability. So essentially you have energy growth limiting the capital deployment. And maybe we'll start a long-term data center development. Maybe we'll say we're building a data center for 2 gigawatts of AI capacity. Maybe we'll spend a couple $100 million putting concrete in, putting the basic building infrastructure. But we will not spend the billions of dollars on chips until we have energy availability. Right? And fundamentally that becomes a buffer or a limiter on how overhyped the industry gets. And energy capacity in the world has been growing 3 or 4% per year, right? And maybe in the AI bubble it's arced up slightly, to like 5% growth in the world for energy capacity, and it's fundamentally limited by nuclear capacity, the renewable capacity, and gas turbines, which now have 7 or 8 year lead times. So that ability to radically increase the energy capacity of the world isn't keeping up with the very rapid rate of announcements of bigger data centers. It fundamentally will limit the overhype of the bubble. So fundamentally, I don't think it has that much risk. Cloud vendors have real economics under their businesses. They're supported by real profits. So it isn't like the internet bubble where you had no business models supporting it. Here you have solid business models, solid business cases for it in the long term, and a natural limiter on how overhyped that investment cycle becomes. What was the third question? Oh, yeah. Yeah, I think Taiwan, one of the fundamental issues, if Taiwan was to play a more prominent position in the world's innovation cycle, is more software. Right? And for it, you're the place that hardware, right, realization occurs for the world. Right? It all happens here. Not a place that's known for your innovations in architecture or software. So to me, if I was planning policies in Taiwan, I'd put a particular focus on those areas because some of the hardware limitations are limited by the natural resource limitations of Taiwan. Today, the greatest issue in Taiwan, right, isn't even software, right, and architecture. It is energy. Right? You are not in a position to have a resilient energy supply chain, and that I think puts your entire industry in a very precarious state. You need more energy resilience in Taiwan if you're going to continue to grow the economy of Taiwan.
Thank you, Pat and Peter. Due to time constraints, we're now. 现场还有媒体要提问，是不是？好，来最后一个媒体朋友们 ，OK。Okay, our final questions. Thank you.
Pat and Peter. This is Tim Fan with Nikkei. I hope to ask you, because you say that previously you are all both of you, maybe you are CEOs, but now you turn to a different lifestyle as VC. And how do you adjust that, becoming advising other CEOs and listen to other things? And then how do you find the balance in this? And then if in any case, will you still go to take another CEO's position, and what will interest you?
So I've done 51 public earnings calls as a CEO, and there will not be a 52nd. Right? One of the hardest adjustments of not being the CEO is not being in charge. right? As I would say, my hands were on the wheel for 51 quarters. And for that, adjusting to being a coach, to being a partner, to helping the CEOs, and being an advisor to them, as opposed to directing them. I'm used to being in charge. Do this. Right? No, it's like, I think this is a good idea to do. And that adjustment is one I'm still making. But hopefully the portfolio customers will, or CEOs that you see here, they will keep telling me where I'm not to do their job.
So I have to say, the singular pleasure of working at Playground with people like Pat and our incredible CEOs and entrepreneurs is that you get to operate at a different level of abstraction. We are working with companies that are producing novel results in biology, in health, in computation, in robotics, in AI, in quantum. That's something that no CEO ever gets to see and do. And as an engineer, I get to go home every day knowing something I didn't know when I came to work. I get to collaborate with people who are responsible for some of the fundamental technologies that are driving this innovation and seeing the young, brilliant talent creating the future. And there is no better vantage point to deploy engineering capabilities and capital against the opportunities that these guys are creating. So I'm never going to be CEO of anything ever again, but this team of CEOs are creating the future in a really profound way.
And the joy of building great companies through great CEOs and leadership teams across a broader portfolio of domains than I could have ever done myself as CEO of one company. This is truly a thrilling period of my life, and I'm making that adjustment. But I do think that this could be the most productive period of my entire career in this role.
Last question? Yes.
Pat, could you share a little bit more detail about Playground's cooperation with Foxconn or other Taiwan companies? Thank you.
Yes, Foxconn is was one of our first round of investors at the very beginning of Playground over a decade ago. So they've been a seminal partner for us over time. And this visit, portions of it are being co-hosted by my dear friend Young, who is joining with us to help to host some of the events we're having as part of this trip. And a number of our portfolio companies have deep relationships with Foxconn. And a relationship like that is we need to bring value to Foxconn as well as Foxconn bringing value to us. So we see that our portfolio companies have deep areas of potential benefit to bring to Foxconn as they launch new product areas in robotics, using our robots, being able to be design and delivery partners into the ecosystem. So we would look for many relationships in Taiwan, and if they were, and any of them were even remotely as close to beneficial as Foxconn, we'd be very happy. Foxconn is a great partner for Playground.
Thank you to all medias for joining today's interview sessions. Because Pat and Peter have other schedule, so we'll conclude the event today here. Thank you, Pat and Peter. Please make your way back to your seat. 非常谢谢所有媒体朋友们的提问啊，谢谢大家今天参与。那因为时间的关系，待会 Pat 和 Peter 呢还有其他的行程，所以我们就在这里先告一个结束了。但如果您还有任何问题的话，你可以跟我们的工作人员来进行联系啊，都会来协助